Hi, my name is Caitlin, and today I'm going to be talking about my favorite part of the brain, the lateral geniculate nucleus. The lateral geniculate nucleus, or LGN, is located in the dorsal thalamus of the brain. It is named after both its lateral location and its shape. The term geniculate in its name actually comes from the Latin word for joint, or bent knee, and as you can see, the LGN has a prominent bend in the middle, resembling a knee. You will also notice that the LGN is situated between the eyes and the visual cortex. This is because it is responsible for organizing and sending visual information from the eyes to the occipital lobe for processing. So now that we know a little bit about the lateral geniculate nucleus, why is this particular structure my favorite? Well, to begin, I think the eye is absolutely fascinating. I will be attending optometry school in the fall, so much of my passion is centered around the eye. While I might be a little bit biased, I still think the eye is one of the most interesting structures of the human body. Not only does it influence how we see the world, but it is heavily integrated with so many other systems. Thus, when it came time to choose my favorite brain structure, I chose the lateral geniculate nucleus because of the critical role it plays in vision. However, despite its importance, I feel that the LGN often gets overlooked. In my previous anatomy courses, we talked about the retina and the occipital lobe. However, not as much time was spent on the lateral geniculate nucleus and the role it plays. Currently, I work as a technician at an eye doctor's office where I get to take retinal scans like this one every single day. Within this scan, you can see the optic nerve and the macula located in the back of the eye, or the retina. While the cells in your retina collect important visual information, there is a whole other component to vision that is not shown in this picture. So where does the lateral geniculate nucleus come into play, and why is it so fascinating? Well, looking at this image, you can see the optic nerve leaving the retina where it then continues to the lateral geniculate nucleus via the optic tract. The majority of the axons in the optic tract synapse in the thalamus at the LGN, which then organizes, filters, and sends visual info via optic radiations to the primary visual cortex, where that information is received, integrated, and processed. The LGN itself is made up of 6 layers. The most ventral 2 layers, or the bottom 2 layers of this diagram, are the magnocellular layers, which receive information from the M cells in the retina. The other 4 layers are the parvocellular layers, which receive information from the P cells in the retina. As shown, you have 2 lateral geniculate nuclei, one on each side of the brain. However, what is really interesting is that each LGN receives input from both eyes. As shown on this diagram, a single lateral geniculate nucleus has layers containing both ipsilateral and contralateral input. So how is this possible? Well, as you can see, the previously mentioned optic nerve divides here at the optic chiasm. The temporal fibers of the optic nerve continue on the same side ipsilaterally, and the nasal portions cross at the optic chiasm, continuing contralaterally or on the opposite side. So this means that information collected from the left nasal retina and the right temporal retina, both shown here in blue, make up the left visual hemifield, which is processed on the right side of the brain, also shown in blue. The opposite is true for the other side, which is shown here in red. You may now be asking, how does the LGN relate, and why is it so cool? Well, the LGN functions like the traffic control center of the visual system. It organizes an incredible amount of information and makes sure it goes where it needs to go. Imagine arriving at an unfamiliar train station or airport that has no signs or directions. It would be incredibly tough to make it to your destination or accomplish what you need to accomplish, demonstrating the importance of the role the LGN plays. Since it is in charge of so much, this begs the question, what would happen if the LGN were to malfunction? Lesions to the LGN can cause visual deficits and may lead to severe visual impairments or even blindness. As you can see on this diagram to the left, the severity of vision loss depends on the location and the size of the lesion. It must also be noted that without the lateral geniculate nuclei, we would be unable to process visual information regarding shape, color, motion, and more, which would most definitely impact how we see the world. So, to summarize, why is the lateral geniculate nucleus my favorite part of the brain? Well, as discussed, it has an incredibly complex structure. It plays an integral, underappreciated role in the transmission of visual information, and it allows us to perceive the world the way we do. Thank you for watching, and I hope you now think that the lateral geniculate nucleus is as cool as I think it is.